Hello all, myself Suresh Kumar. This is our 14th class. In this class we will discuss about timer 1 and timer 0, timer 0 and timer 1 and timer 2. We will discuss about timers. Create a project for timers. Just firing up the project window. Create a new project. Now I am creating a project for timers. First we need to know about why we are going to timer concepts. So this is also same like interrupt concept, but this timer concept no need to externally giving the interrupt. This is also internal interrupt. Timer is internal interrupt. When this occur, when this overflow the timer container, that time only the interrupt will be occurred. So this is also interrupt concept, but it has an internal activity. It's the processors making creating interrupts. Self interrupts. This is called self interrupts. First we need to configure that self interrupt, then only we can use it. Now I'm creating normal IO for switch on and off the two LEDs. See this output toggle, just it will be glow. This is the main part. Then wait for 3000 milliseconds, means 3 seconds, and then D1 is on. Wait for 1 seconds, 1000 milliseconds. Now I am going to simulate this. See what it happens. First D1 on, D2 on, then D1 on, again D2 on, off, D1 off, D2 on, D1 on, D2 off, D1 off. See what it happens. You understand that? Okay, I will explain it. If this target pin is, this T0 is on first time, wait for 3 seconds. After 3 seconds only this D1 pin is on, so it is waiting for on. After 3 seconds is finished, then only this D1 pin is on, which means D2 LED is on. After 10,000 milliseconds, which means 1 second, then only D0 off, waiting for 3 seconds, and again this is going to be off, wait for 1 second, and then going to on, wait for 3 seconds, on, wait for 1 second, off, wait for 3 seconds, wait for 1 second to off, wait for this again and again and again doing. But if one process is executing, that time this line is waiting for execution. You understand right now? Yes. Here I am implementing timer 0 concept. This is the subloading part for timer, and this is the main part. Here is the pin D0 is toggling every 3 seconds. This is inside the loop, so this process is doing again and again and again repeatedly for 3 seconds at once. Here this is the setup part of timer 0. setup time as 0. RTCC internal means it has an internal clock, and this clock is divided by 256. This is called a prescaler. And enable the interrupt RTCC or timer 0. We can use RTCC. This timer 0 is an 8-bit timer, and enable the global interrupt like main switch. Here it is. I created a variable with initialized 0, and once I enter in subloading part, the A will be incrementing at once. Then if check if A greater than or equal to 30, that time only that pin is toggling. When this process is complete, again I will reset this variable. Then set the timer 0 to 150. It means I will explain it in Paint. Okay, it is hard to understand, so that's why I am making like this. Okay, I will explain in this class later. Okay, this is the thing. We just build it, we succeeded, and then run it. Now you can see this. Two LEDs are glowing, blinking the same fast. This is, I think, this is 3 seconds. D1 is 3. D0 is 3 seconds for blinking. 3 seconds, and this D2, which means timer part. This blinking every 900 milliseconds or around 1000 milliseconds, which means 1 second. But see this is operating. If this glowing, that time this is also glowing, and this blinking, that time also this is also blinking. You think this is multitasking. D1 also blinking at different speed, D2 also blinking different speed. You can see it. See, right now this is blinking, this is also blinking. D1 is off, but D2 is off, on and off for every 1 second, and D1 is on and off for every 3 seconds repeatedly. This process is not affect D1 process is not affect D2, D2 process is not affect D1. This is multitasking. This is called multitasking, single core based multitasking. This is also for multitasking purpose. Here timer 0 is an 8-bit timer. 0 to 255. Timer 0 is overflow interrupt. This is 0 to 255 is container. We set this is the predefined set. We can set it from 0 to 255. If we set here 0, 1, 2, the timer will be incrementing from 0, 1, 2, 3, 4 up to 255. When it 256, the time the interrupt timer 0 interrupt will be occur. Again this come to 0, 1, 2, 3, 4, 5, 6 up to 255. If the counting going to 256, the timer overflow interrupt will be occur. Again this process is doing. We can set this from 0 to 255. We can use if I setting to 150, the timer starting from here it is 0. The timer starting here 150. I think here is just think here is 150. The timer is counting starting from here to 256, which means quickly overflow, quickly overflow, quickly overflow, quickly overflow. First time going to here and then overflow, then come back, overflow, then come back. If we set again and again and again on 50, the timer is overflow and come back on 50, then timer is going to 255 and overflow and come back on 50, then timer is go overflow and come back on 50, overflow and come back on 50. That's why I'm setting here. It is once overflow, the timer is set by this set timer 0 on 50. Then it will be counting on T1, on T2, on T6 up to 255. After overflowing, the time this interrupt will be occur. This subloading part will be occur. That time the timer initialization is set to 150. This is the concept. I will explain in hard work mode. Okay. This is really important. It has some formula. You can use it. 4 divided by f oscillator and prescaler 256 minus b. B is the your set timer 0. A is the RTC is divided by value, prescaler value, and 4 is why we are using 4. In PIC microcontroller, every 4 tick pulse, clock pulses have executing one instruction cycle. If the clock pulse is completed 4, then the PIC will be execute that complete that instruction, one instruction. So we divided by clock, what we used, what type of clock and what clock speed, that is divided by 16. I am going to calculate this part. See, here it is. I am showing how to calculate this. Minus this is my prescaler value and this is my B value, and my clock speed is 16 MHz, so 16 lakhs, 4 divided by 16 lakhs. So I am using 4 divided by 16 MHz, like 16,000,000. Okay, then click it and again prescaler value. I am using 256 into the same as formula into minus 256 minus I am setting 150 for again and again. Preset the value for time is 0, 1 or 6. I just click it aroundly 6 milliseconds, so 600 milliseconds for 600 milliseconds for every overflowing. Every time after 600 milliseconds completed, the timer part will be executed. This interrupt service subloading part will be executed. Every 600 milliseconds have the timer will be overflow. Timer 0 will be overflow. Timer 0 will be overflow every 600 milliseconds. Now I am counting A plus plus. If A greater than or equal to 30, then it will be toggling that pin. So that's why the pin is glowing 3 3 seconds, sorry, 6 milliseconds, and to 1.8 second. This is 1.8 milliseconds blinking fast. This blinking fast is 1.8 millisecond, and this blinking speed is 3 seconds, 3000 millisecond. So this is the concept, and I will explain in timer 2 and timer 1 and timer 2 in next classes.